Hello, my name is Olena, and in this video we'll look at how partitioning actually works in Apache Kafka. Starting with the default partitioner, there are three ways to determine into which partition the records should be written. Here on the left I have a producer, and on the right I have partitions distributed over different brokers. When selecting a partition, the first thing the partitioner will check is if you explicitly specified the partition number where the data should be written. Usually you don't want to do this, but in case you have to, you can. I call it micromanagement and would rather discourage this usage. However, good to know that we have this option, and this becomes quite a valuable option for some edge cases that you want to solve when distributing the data. Next, if you didn't provide that explicit number, the partitioner will check for the key. If the key is present, the producer will take the hash of that key, do the model on the available number of partitions, and then use this number to decide where to write that records, where that record fits into which partition it should put it. The idea is that we want the same key to always correspond to the same partition. This allows us to guarantee that all messages with the same key will be stored in the same log, in the same partition, and the order of those messages with the same key will be preserved. Because in the distributed world, in the distributed systems, we write data here and over there, and then somehow we connect and process it. But if you write those records into different machines located in different places, later it's quite tricky to say what was the order, which message came first, which message came second, and so on. Unless we write the data, the order of which is important, into the same partition, into the same log file, then we can really say what message was first, what was second, and what was third. Looking at this formula, spoiler alert for the future section. Think what happens if we decide to add more partitions to the topic later in time. And in this formula, we change this value. And this will affect the partition number which we will have for our key. And this is exactly why adding more partitions might not be as easy as it seems at first if you're using keys. Not impossible, but let's say you want to think twice. But for now, let's move to the third case. What if you neither specified the partition number explicitly, which normally you shouldn't do, and neither you use the key? This is where we ask Kafka to distribute the messages across the partitions in the most effective and efficient way, performance and all those things. And in the old days, the default partitioner was round robin, which was iterating across all the partitions and spreading the records one by one to achieve the best balance of data. However, it is important to understand here that round-robin partitioner doesn't really send the records immediately. So it's not like it will have a new record and send it there. No. It will actually send batches of records, because sending record one by one will be such an overkill for the system. So it will first buffer the messages per partition, and then it will put the first message here, second there, and so on, and go one by one, and then will send those batches to the cluster. And this results ideally in a nice and even data distribution. However, this approach has one issue. It's not really that optimal. Here in our very primitive example, we are sending 3 batches with 2 elements each. Instead, we could have sent 1 batch with 6 elements. Smarter batch sizing means less network traffic and less load on the brokers. All the positive things to improve the performance. And this is exactly why we have a new sticky partitioning approach. And from Kafka 2.4, okay, that's not that new, it already exists for a while, but still, that's what came after the round-robin approach. So from Kafka 2.4, the default partitioner is sticky partitioner, and it will select a partition. Then it will continue assigning the records to a batch which it will keep locally till one of 2 conditions happen. Either the maximum maximum time that we allocated for that operation elapsed, or the batch reached its maximum size. And when this happens, the producer will send the batch to the selected partition, create a new batch for the next partition, and the idea is that over time the records will be still spread evenly across partitions, so the balance of the cluster won't be affected. As an advantage of this approach comparing to round-robin approach, we gain a significant reduction in latency, around 50% according to the benchmarks, and 15% reduction in CPU utilization, which is impressive. But as with everything else, those benefits come with some new stuff to pay attention to. For example, new corner cases where this even distribution of data turned out to be not that even. We will discuss it shortly in one of the next videos. But coming back to the settings you can use with the sticky partitioning, you can influence 2 properties: linger ms and batch size. By setting them, you determine the time window for the batch and the size of the batch. The default for linger ms is 0, and most probably you want to put it a bit higher to allow better throughput and allow batches to accumulate more data before sending them to the cluster. Same for the batch size, you probably want to assign the size according to the needs of your system. So to summarize, remember that there are 3 ways the default partitioner determines how to distribute the data. First, looking for exact partition number. If you don't have it, using the hash of the key, and if that is not present, then using sticky partitioning. If you don't like either of those options, you're picky. But that is fine too, because you can create your own custom partitioner and implement custom logic. This is very handy when, for instance, you can't use the key for partitioning but want to rely on another record property, or you want to combine several properties of your records to decide where to which a partition record should be written. Now that we talked about the options we have, we need some motivation to select a good strategy, and this is a topic for the next video. Leave any questions or comments you have in the comment section below, and if you enjoyed this video, please like it and subscribe to the channel.